All right. Welcome, everybody. Tonight's Revit User Group. So the agenda we're going to go through tonight is a brief introduction to Core Studio, who we are, looking at some of the apps that we've developed in-house at Thornton Tomasetti, and then looking at some of the modeling projects that we also work on in Core Studio. Second up is going to be a look at the recent Symposium and Hackathon from 2019. I'm going to introduce a couple of the projects, not all of them because it was a long list. We'll talk briefly about the winner of this year. I do have links to the GitHub sites, so you are able to get into the open source backend code if you want. I will say I was not on many, well, I was not a member of any of the teams I'll be talking about, so I'm speaking for other people's work here as a caveat. And finally, I'm going to introduce Swarm for Revit, which is one of the apps that we think is going to be really useful for the wider marketplace, which gets into leveraging of Rhino compute. But anyway, we'll get there eventually. So I'm going to basically introduce Core. Sasha's going to talk about some of the apps, Jonathan about the modeling, and then I'll be doing Symposium and Swarm. So who we are. Who's heard of Thornton Tomasetti here? Most? Nobody? All right. So we're a structural engineering firm primarily based in New York, but we have offices all over the world. We're about 1,500 people at this point, which is a lot more than when I first started at TT. We have many practices, and Core Studio sits in the corporate side of the company, but basically as a resource for all of the branches of our firm to ask questions, get tools made, solve workflow problems. So we probably do most of our work for the structural engineering side because that's probably the biggest chunk of Thornton Tomasetti. But we also build apps that cover pretty much all of these practices. Like I said, we're a big company, lots of offices and lots of places. New York City is the home office. And we actually are going to be merging with our downtown office next year and a brand new site on Wall Street, which is quite nice. So who are we? Like I said, we're a group inside of a larger structural engineering company. Our mandate is to be a firm-wide incubator of ideas. So we essentially try to increase the value we bring to clients through innovation. Our goal is to take ideas from the firm as a whole and kind of shepherd them through the process to an actual tool that can be developed and deployed firm-wide. We are quite a large team at this point. There were 3 of us when we started, and now 7 years later, we're at almost 20-something. You notice there are 2 kind of branches here, and there are some duplicate faces. So Construe is one of the first apps we've actually released globally to external users. So kind of we wear 2 hats in some cases. We work for Core Studio, but we also do work for Construe itself, which is a separate entity. Okay, I'm going to hand it over to Sasha, who's going to talk a little bit about the Core apps.
Hi, everybody. My name is Sasha. I work in the Core Studio, and I'm going to introduce some of the apps that we develop. There are 4 major trajectories that we have at Core Studio, which is automation, interoperability, visualization, and structure. Today, I'm going to introduce 3 of the apps, which is one is Construe. It's an interop app that allows multiple platforms to talk to each other and to translate models. And also, I'm going to introduce 2 of the visualization apps, which is Mirar and Thread. Construe is an application that allows to translate a model between multiple platforms. It can be structural, architectural, and any other one. First step to upload the model to Construe is to upload model to the online cloud, which we have clients in multiple platforms, and the upload process is really easy. It only takes a couple clicks, but it uploads all your geometry with all the attributes. So from Revit, for example, you can bring all the families and categories. And this web viewer allows you to visualize your model by different types of elements. And as well, you can see all the changes that you made in the model. So as your project progresses and you upload multiple versions of the same file, you can see what changed, like which elements changed or which elements were created or deleted in the model, which is very useful because sometimes it's really hard to track all the changes, especially when you have a big team and multiple offices across multiple cities. And here is kind of an example of collaboration using Constru. A model is being created in Rhino and Grasshopper, and then it can be easily exported and translated to all these multiple platforms with all the attributes attached to it. So it's not just pure geometry, it's all the information that is so important and necessary for collaboration. Second application is Mirar, is a web viewer. I'll try. So this is an example of a model that it's a Revit model that's been brought to Mirar. Mirar is a sharing and viewing platform. It also brings all the attributes of original model. So for example, here we have different families and object types, and you can easily color this model by attributes in the web viewer. So it's really easy to see all the elements and also to share this with collaborators or with your client. Mirar models are really really easy to upload on the web and also really easy to access from any mobile device, any device, even your phone. And Thread is another visualization application which takes a CSV file as an input and allows you to create a dashboard to represent your project. We have a lot of different widgets that you can see right here. It's different kinds of diagrams and images that you can place on your dashboard to create a report about your project, for example. Also should mention that these two apps, Thread and Mirar, can talk to each other and the models can be linked. So if you would like to filter some elements in Thread by certain aspect, those changes or visualization will be, you can view them in 3D in real time in Mirar Viewer. This is another example. So this was a Revit model that brought to Thread, and here on the left, you can see two widgets that represent the types of geometry that exist in the file. And on the right here is the Mirar viewer. So it's a 3D model that can be rotated and explored, zoomed in or out, and cropped in any way. And when you filter you can select one of these objects here, and it will filter and color the elements in your 3D model by the attribute that you select. So it can really help you to visualize your model. And it's often really hard to see some elements of the model, and this allows you to visualize them really well.
Try and save a couple of these videos. I know it will work. PowerPoint can be quite painful. Put a lot of work into making a live demo for a video. The video doesn't play. restart will do. Yeah, so the first app that Sasha mentioned there. Yeah, but this is a Microsoft product. Microsoft product. Yeah. Okay. Will this play? Yeah. All right. So we'll just do it at this scale. So this is a Revit model. We uploaded to Construe. We're going to visualize first of all by type of object. So you can color by type. Show me all the floors, all the walls, all the beams. In addition to color by type, because this is a database, and every time you upload to the database, you're creating a new version of the file, we can actually visualize by change. So in this case, we're looking at the model and we're seeing that since the last update, 328 objects were updated, and we can actually zoom in and see that it was actually the properties for the facade columns. Click on a facade column and it'll actually tell us what the size was before and what data changed after. We have a fix for the videos, but I'll just keep moving it a little bit. Sorry, Sasha, to jump in. All right, Mirar. So this is a button that we have inside of our Revit platform. You click upload and it takes a Revit model, uploads it to a website. This is not quite as detailed as Construe, but you can see that you get all of the Revit properties attached to it. So it enables you to make visualizations by, let's say, color by work set. Show me all the objects on every single work set and then give me a visualization of those colors in the 3D view. This is just work set. Any Revit parameter or data attached can be filtered by in the Mirar view. We've also got controls over extents, clip planes, transparency, most of the things you find you want in a 3D visualization. Like I said, all the data is still attached, so you click on an object, you'll get the attributes and properties on the left. Like I said, clipping regions and all that fun stuff that makes large 3D models much easier to kind of handle. Most of the time, we're only really investigating one floor plate at a time. So these are apps basically we've developed for TT to increase our collaboration and efficiency. If TT people want to share a Revit model with someone who doesn't have Revit, they upload to Mirar, and they've got pretty much a licenseless 3D model. Next little demo video, I think, is some more Mirar. So we don't use it for just BIM models. We do a lot of steel detailing. So this is a Tekla model. We do our structural analysis. So this is taking our analysis models and extracting relevant data and making visualizations our engineers would otherwise be unable to create in their native platforms. It's really just data visualization, taking objects with information and giving the users a different way to show it on a screen. Grid. This is a really nice video. Okay, so Mirar was our first step, making just 3D visualizations. Then Tableau became a really big deal, and we decided we had to get into dashboards. So this is taking a Mirar model and tying the visualization to attributes that can be filtered through widgets in a dashboard. So show me all the beams of a certain category in the model. Show me all the objects over a certain force level in the model. I'll leave this one quite long, but we're uploading images, we're uploading data sets. Here's our dashboard. Lay out the widgets you want, choose the graph types that make sense for the visualization you're trying to make. Lay it all out, and then start filtering through your data. Did anyone here have experience with Design Explorer in the past? So Design Explorer was a parallel coordinates chart, pretty much similar to what you see on screen here, developed by Mustafa from Honeybee way back in the day when he was an employee of Core Studio. So we're taking that to the next level with Thread, having the ability to add many different widgets, not just parallel coordinates. You can even do search bars. So Revit model search is a possibility with Thread and Mirar. The last video we have here, this is another one that's showing a model uploaded from Revit, and then using the widgets on the left, all the properties are there, just like you would see in Mirar. We can start to color by or select specific objects from the model and then apply the graphics on the left to the model on the right. So it's, much of the stuff you can do natively in Revit if you're pretty savvy with filters and all that carry on. Our goal is to build stuff that even the most basic Revit user has to click one button and go to a website, and these are all prepackaged for them. So there's very little effort on their part to put it together. The last one video here is a specific one to structural models. So this is where we're visualizing the number of studs as a property on the objects in the steel framing. So that graph on the top there is showing you the length of the object versus the number of studs applied. That's the ratio we're looking for here. And again, as you filter through the graph, you're going to have the model visualization update based on choices made from the widgets on the left. So it does depend on models being data rich to make use of this information, but we kind of assume that with BIM models, we're just making more and more data rich models as we go. Okay, so that's the end of that section. Jonathan's going to jump in now and tell you a little bit about core modeling. I think we have some videos in here too, so you might want to, I can't remember. Is it a GIF? Want to leave like want a full screen or because try full screen. I think you guys might fail.
Okay. Hi everyone. My name is Jonathan. I'm with Core Studio, more specifically Core Modeling. I'm one of the computational designers there, and I'm going to tell you a couple projects we've been working on or have worked on that kind of reflect the stuff that Core Modeling does. To start, we're going to talk about Pittsburgh Airport. More specifically, we're going to talk about its roof, which is what Core Modeling got tasked with. It has to deal with a series of many conditions, and we went through all sorts of different softwares, including Grasshopper, Rhino, Construe, Revit primarily, and SAP, among others. The Pittsburgh Airport, one of the biggest challenges was sort of solving its roof. You saw the architects kind of like undulating roof systems. They tasked Core to figure out different ways we could, in collaboration with engineers, create structures for the roof, along with spines and along with all sorts of different design iterations. Ultimately, we ended up on a more simple design iterations that was consistent of a series of bays that would run along each individual ribbon. This is the one you see on the screen here. To get to this point, though, Core Modeling had to go through a lot of different parametric solutions, ultimately building a script that let us generate a series of framing that then we could import into Revit and then create drawings from it and so forth, which from the engineer's point of view is absolutely amazing because it would save time. But from the architect's point of view is also great for them to be able to make changes to the roof, generate framing, pass it back, continuous feedback loop. Also, it was great about using the softwares that we have in hand, like Grasshopper and Construe, would let us easily go between different other analysis platforms, or Revit, which is more like BIM and drawing platform, and so forth. And then any changes that came our way, we would obviously go in and try to create the script that could accommodate for such changes. Now, one of the things about Pittsburgh that kind of stood out the most was the fact that it was so detail heavy. As you notice, there's these sort of columns that stand under it, kind of like tree columns, as you see in the bottom right over there. And what was interesting about that is that at first, they were all very unique. You have this undulating roof structure. How do you solve for something that's unique and make it a little bit more standard? In other words, don't blow up the budget. Which you started then looking into other different ways of optimizing. Say we took the roof themselves and started having the roof talk back to the columns, and maybe we could optimize the angles between them, which is what this little animation is showing you here. It's an optimization. Trying to figure out how we could take all of those nodes that represents the columns and minimize them to a series of types. Instead of having like 20 different column types, we have a series of maybe 10 or 8 or 7 that then we can just cast repeatedly. Saves budget. It also helps the architect keep designing, but maintain its aesthetic, and the engineer keep its sanity. We're not having to size all these different unique members. There, hold on. And one thing I wanted to also note about, talk about Pittsburgh Airport is that it was one of the projects that really emphasized the sort of communication between design, sort of the architects using a lot of Rhino and Grasshopper, and then Revit, sort of, you know, the BIM platform that lets you kind of do everything that we all know how to do now. And thanks to the tools we developed in Core Studio, primarily Construe, we were able to seamlessly go back and forth, creating models that then we can update in Revit and not having to regenerate an entire new set of frames within Revit. And then here's another project I'm going to quickly touch on, which is more on the design heavy side, but specifically in this case, Core Modeling was tasked with helping helping fabricate the facade. In this case is the Lucas Museum of Narrative Art, and Core Modeling of New York City, along with the LA structure team of Thornton Tomasetti, was tasked with basically rationalizing the thing you see on the exterior, this crazy looking facade. That's kind of what I'm trying to explain just now. You have core modeling TT facades, trying to figure out the bits in between, and then other engineers working on the interior structure, and then facade sub working on the, well, fabricating the facade. Now, what was particularly different about this project compared to other projects worked on is that it was essentially one giant Maya mesh. I don't know if you guys are familiar with Maya, the modeling platform, but it's just, think of it like just a crazy mesh in space that has absolutely no dimension, no measurements, no kind of sensibility for fabrication. Once we got the model, we then have to talk with TT structures and try to rationalize a way we could then take this into pieces. In other words, discretize it into regions, ribbons, and panels. We looked at the topology of the thing and started looking at how we could create ribbons. Each ribbon is then composed of a series of panels that then we could then think about structuring back and forth. Ultimately, taking something that looks almost alien, like a spaceship, and bringing it down to reality, something that we can actually build. Along the way, we worked with the engineers and as well as the fabricators trying to figure out different structural assembly concepts, how we could begin to look at primary, tertiary structure, and then connecting back into the main structure while still maintaining an overall aesthetic of the piece and not creating an over complex design. And this, what you see here, is kind of just like a series of beams. They're attached to a series of ball hitches, but they're attached to trusses, which then connect back to the major structure. And then the arc represents one of the panels, because as we saw in the previous images, none of these panels are remotely straight in any way, shape, or form. Actually, now that I said that, one of the things we do have to look at is planarization, which using Grasshopper and Rhino, we were able to quickly generate all these different conditions and look at planarization, look at different ways we could create panels that could then inform placement of elements, members, and frames. Ultimately, once we got a workflow in mind and established, we were able to quickly start developing and testing the overall facade, and then creating a series of center lines. The benefit of that is that once we create a series of center lines, we can then translate these pieces of information into any other software. It can be for analysis, or it can go straight into Revit, which ultimately this thing had to go into Revit, which the workflow. No, it's fine, it's fine. Anyway, so there was one other thing I want to say is we were talking about the workflow of the Liebskind, where it started out pretty heavy on Rhino, Grasshopper, and pretty much going straight into Construe, and then to SAP and other analysis platforms. Ultimately, once we created all these sort of centerline models, we could then have the center lines being formed properties and then bring them into Revit. So then we could start using Revit to create all our drawing, documentation, and so forth. And eventually creating something that's out of kind of like out of this world looking, but making it rational. Of course.
Okay, Symposium and Hackathon. So I guess most of those projects you saw there did involve some sort of mashup, the taking models that we generate in places like Grasshopper and having to translate elsewhere. That's usually because the platform you're working in may not give you all the tools you want. So modeling in Revit is not the most fun, but you can do a lot of modeling in Grasshopper, and then solving that link is what facilitated most of these projects. I'm going to talk about Symposium Hackathon now. We have quite a few projects in here that are trying to solve the same problem, the different softwares, which is why I bring that up. If you need it, this here is a link to the GitHub repositories for all the projects I'm going to be presenting today. In most cases, open source, so everyone uploaded their space from the weekend. In this presentation, I'm going to do a brief review of some of the projects, as well as a depth review of the winner this year, which was Gangaru. We've been doing this for a lot of years now. I think even before 2013, when there's some logos back there. So I guess we're in our 7th or 8th year of doing the Symposium and Hackathon. Hosted every year, September in New York. We have actually now also expanded it out to do multiple events around the country. So I think we have a Hackathon Symposium in Georgia at the Georgia Tech Institute, as well as in Seattle currently. But we are looking to source it out. So it's made up of 3 things: a series of workshops, which is basically us getting our really fancy, smart friends in the room to teach people some skills, be it coding skills, Rhino skills, Grasshopper skills. I think we had a little machine learning course this year. The symposium is presentations. So first day workshop, second day symposium. where we get some of the more kind of leading voices in the industry to talk about projects or things they've worked on in the technology sector for AEC. And then the last event is the hackathon, which essentially occurs over the weekend. Thursday workshops, Friday symposium, and then Saturday, Sunday, 48-hour hackathon. I think this year was our most well attended. We had 85 or so people, which is huge. I think the fact that we do this every year has given us a pretty good reputation, and people are really kind of catching on. Our sponsors for this year, got to have the sponsor slide up there. Dassault Systems, who's heard of Dassault? Okay, so they're trying to get a little bit into the BIM space in the States with some new products. Still on the higher end of the market, but very fancy. They're great software, great geometry kernel. Got lots of good things to say about them. Proving Ground, obviously old friends of Core Studio, as well as Ladybug, thanks to New Balance. Rhino was a big sponsor this year, which you'll kind of get a taste for when we get to the swarm app situation. And the Architect's Newspaper. So this is a quick picture of the symposium. We host this at Baruch College. I think there's probably close to 200 or so attendees to this event. We host presentations as well as kind of a round table at the end where we try to get a good conversation going between not only, let's say, VCs in the AEC industry, but all the way down to the actual people who are writing the code in the hackathon. We want that conversation to be as inclusive as possible. These are some of the workshops we hosted this year to give you a taste for what was given, and probably similar stuff will be given again this year. So we obviously try to push some of our own apps on people, model and data visualization with the core apps, Rhino Grasshopper, practical use of AI within AEC sector. We have a pretty good, let's call it image recognition AI platform at TT called T2D2, designed to take pictures of facades and find cracks. Good name, right? Half the battle's the name. And that was a workshop focused on giving people an introduction to setting up data sets for image recognition. We had New Balance giving a more geometry-based session, as well as Nate from the Proving Ground doing data visualization. Mustafa was in the house giving Python courses, mostly specifically on Ladybug Honeybee stuff. And then Dassault gave a visual scripting workshop. That's kind of the range of events we try to provide. Brief image of the workshops. These are hosted actually at our offices at TT. Bunch of geeks with a bunch of laptops talking about AEC stuff. All right, so the hackathon. This is a brief overview of some of the projects that you'll find on the GitHub repository. I'm not going to be speaking about all of these today, just a couple of them. All right, Airbud. Who's here heard of Airtable? Okay, so Airtable is a web-based database. It's kind of like Google Sheets, basically. It's a little bit smarter than Google Sheets. So we had a team here who looked at that really nice platform, looked at Rhino, and decided we could make Rhino a better BIM platform by tying it to a database. The goal here was to take a Rhino model and actually link it to the Airtable platform. So Rhino objects can feed and be read from a Airtable, and Airtable data can be fed back to Rhino. So another mashup problem and another mashup solution. Again, like I said, the GitHub code base is available via that link. Next hackathon project, ArcRhino. Anyone use ArcGIS in the room? Oh, okay, so in this case, another mashup. They see benefit in using Rhino for AEC modeling, but they also have a lot of issues getting good GIS data into Rhino. There are some Grasshopper plugins that do this, but the goal with this project here was to essentially take ArcGIS and the new Rhino Inside libraries Rhino have released to open up their code base and try and literally directly link ArcGIS to Rhino. So mapping environment, ArcGIS, choose an exchange format, convert and import, and then design. All they were trying to do is smooth out that process. Most of the time people come to these events with problems that they have in everyday life, and this was one of them. And the concept here was to just try and make a button that would solve 4 hours worth of work for them over the weekend. They did a pretty good job, I would say. Punch Boss. This team showed up with a robot, which we always appreciate. They had a little, again, I'm not sure the name of it. It's basically a big old Roomba looking thing, circle on the ground there. Their goal was to automate essentially data capture from construction sites. So they had a little camera and a little sensor placed on this robot. I would say they were the most ambitious in their project, but probably, you know, they had the best demo. Let's put it this way, they had a robot that moved around. At the end of the day, they were looking specifically to try and get digital mapping from the camera onto a line with a ground plane. That was the real technical issue they were trying to solve. This, by the way, is just an image of the robot in use, not from the hackathon specifically. The goal was to do sort of an augmented reality approach, tie the ground plane to the camera inside the robot. Regular expressions. Anyone use regular expressions? Okay, so these are a set of, basically a set of syntax for code. And they're very useful for automating checking of data. You can very quickly write a couple of lines that will do a lot of work in terms of looking at text, changing text, altering text, which can obviously be very, very difficult to do inside of a Revit model. I'm sure everyone's familiar with Dynamo and the ability to make wholesale changes across a whole bunch of Revit objects with Dynamo. The goal with regular expressos was to give that same functionality to a Revit file. So build a little WPF form in Revit where you can launch a regular expression interface, write regular expressions, and have it feed into your Revit model and select objects from your Revit model. This was something that the guy who developed this actually worked on his own on this project. We don't really like one-person teams, but he was really, really into the idea and really wanted to get it out for the hackathon. I think he got about halfway there. He would have done better with a team, but you know, that's his choice. Best open source was RT-ish Flow. It's essentially trying to link fluid dynamics and Grasshopper with Revit files. Now, this is essentially taking existing libraries inside of a Grasshopper model for CFD analysis and then trying to integrate that into their Revit file. Again, another mashup between two software. All right, the best overall hack this year went to a team called Gangaru. This is a very impressive project. I have to say, I'm pretty sure they came with some libraries in their back pocket because they did such a good job. And I'm sure you'll all be very impressed. It does leverage a tool released a couple of years back called Pix2Pix. Anyone heard of Pix2Pix? Okay, so if you've heard of Pix2Pix, you'll probably get what these guys were trying to do. So as architects, we do a lot of sketching in our lives. If you're fancy, you can do 3D sketching. But there's obviously a big gap between a two-dimensional sketch and the rich 3D models that we're all used to building at the end of the day. So these guys, the pitch was, what if there was a way for you to sketch in 2D and then directly translate that into a 3D model? Sounds crazy, right? But this Pix2Pix platform is very useful. So what they're doing is they're taking an image, RGB values, and breaking it down to try and get a depth map out, as well as an edge map and a contour end. So taking an image, breaking it down to a series of layers that they can abstract from to try and generate 3D objects. So imagine I did a sketch of that little box on the left. I would input it to this platform. I would get a 3D box on the output. That's the goal of the tool. I think they did a really good job in presenting. Like I said, I'm not sure how much was actually done in the hackathon, but they did end up winning. I do have, we've got a video here. Well, this describes what Pix2Pix is doing. So create a sketch, and through GAN networks, generative adversarial machine learning networks, you can essentially apply some photo properties to your sketch based on a series of edges and infill. So sketch a bad cat, get a really ugly looking cat, but it looks like a photograph. That's the software that they're leveraging to create their app. And I have actually put a link here to a video that describes the paper that they're using to generate their app, which is really fun to see. So I highly encourage you to look at that. And there is a video of their app on the GitHub site as well. I unfortunately don't have one here, but the goal is machine learning training. So can you feed in a bunch of photographs of buildings, and can those be leveraged in any future 3D sketch to choose an appropriate form in the platform? That's the goal. Sounds crazy, but I would say they actually did manage to demo a version that showed us the box-to-box solution. So that video is available online. I think I have a couple of stills. This is their tool plan. Obviously, actually getting from that terrible sketch to that beautiful model is too much to ask, but there is a bunch of smoke and mirrors in these hackathons as well. You know, good ideas don't always have to have solutions in the background. So here's the live demo they actually showed. You can see him kind of sketching a little tower with a podium here, and then it's essentially looking at the database of images and finding an image that matches. In some cases, they were able to get the 3D geometry generated. Not all cases, but a very impressive project. Okay, to finish with today, I'm going to talk about Swarm for Revit. So I've mentioned so far Rhino Compute a couple of times. Who's heard of Rhino Compute before here? Who's heard of Rhino, the software? So Rhino recently opened up their library of geometry functions. It's called Rhino Compute. You can set up a web server where you can call Rhino functions and retrieve results. So let's say I take a curve, call Rhino, split curve, I get a split curve back. That's kind of the goal here. Some of the videos you've seen online may be stuff like Rhino inside of Revit, which takes some of the geometry functions that Rhino has and ports them literally inside of the Revit platform. Swarm is our attempt to take that base technology and apply it to the AEC industry. So you don't have to be an expert or a pro, but you can do things in Revit that you couldn't do previously based on Rhino functionality. It's a design app marketplace and cloud solver. We've built this to try and connect. We have a lot of people in our team who are very savvy Grasshopper users, Dynamo users, coders. So we're trying to connect those users to a bunch of other people in our company who don't have those skills, but still want to leverage the apps that we can create in those parametric platforms. So with Swarm, it's kind of 4 different things. There's a design app marketplace. Anyone can create an app, and usually they're coded in Grasshopper, and upload that app to a marketplace. These apps can be free, they can be paid for, they can be sorted by domain. Anyone that works at TT has a set of apps, for example. Anyone can be an author, anyone can be a consumer of apps. We have desktop clients. So when you create an app, let's say a split curve app, currently we have a client in Revit, we have a client in SAP, and ETABS. So you can apply Swarm apps to any of those 3 platforms currently. Anything you can mesh, split, any Rhino commands you can come up with can now be applied to Revit models directly. There's also a developer environment that enables you to make robust apps. This is, again, leveraging Grasshopper primarily. So if you know Grasshopper, you can build Swarm apps. And there's also a web interface. So this tool is kind of combining together all of the things you've seen so far: Mirar for web visualization, Thread for data and web visualization. We've tied all these together with Swarm and Grasshopper backend to develop a really nice tool. So we have a marketplace. So you can go online to swarm.thorntomasetti.com, search for available apps. You have things like tessellation, you might have meshing. These are all up there currently. A tower generator that Sasha here built. You can get the app, install the app. Once you've installed it and you go to your platform like Revit, you're able to run the app from that platform. There's a web player, so any app you create can be run in a website. Don't necessarily have to be in the client platform. So let's say I make an app that creates a crazy roof geometry and the client wants to see it. They haven't got Rhino or Revit. I can share the Swarm app with them. They can actually get control over any of the parameters, change the density, change the height if they so choose. And whenever you change the sliders on the left, what's happening is the Swarm app is calling the definition in the background, resolving it, and pulling down new results. That's the kind of tech in the background. Here's an example of Swarm running inside of Revit. So essentially what we're doing here is we're referencing some columns from a Revit model. Now, TT Core Modeling has built an app that measures trib areas for us. So we have a Grasshopper definition that does some Voronoi work to measure trib areas for columns. We built an app in Swarm. We uploaded it to the website. We added it to our Revit library. And now we can make selections from the Revit model. In this case, to find out trib areas, you need a floor plate and you need a series of columns, which we're selecting here the columns first. We reference them into the app on the left. And then you're going to see the app solve and you're going to get a little preview. Nothing's actually happened to the Revit model here. All we're doing is extracting information and creating a nice visualization of trib areas for our engineers. Fun fact, a lot of engineers do this by hand in a plan view, figuring out trib areas. So our goal here is to automate this process. We have a Grasshopper app in the background, which we can tweak and adjust to the specific user's requests. And we've built an interface so they can actually use it in the platform they actually work in, which is Revit in this case. So this is mostly visualization, no information really hitting back to Revit in this case, but there are possibilities are endless, basically. So this is an app that takes a series of crazy curves that we generated inside of a Grasshopper definition, and we're now running it in Revit and baking detail lines down to the Revit platform. So we have, I think, 5 or 6 object types that we support currently in Revit, detail lines being one of them. We're expanding that list as we go. We're essentially here trying to take Rhino and Grasshopper and tie them really, really closely together with Revit. You shouldn't feel like Revit is slowing you down in terms of design iteration, hopefully with these type of apps. And last one here, this one is a floor framing tool. So this is actually going to demonstrate how we send information back into Revit. Oh, it's going to play, look at that. So Revit's open on the right. There's a series of grids in the model. Swarm is open on the left. What you're going to see is Sasha referencing in grids and the floor plate from the Revit model to the app, clicking run. Notice that that's just going to update the visualization. In this case, it's a little bit trickier because we actually are doing the sizing of the beam as well. So in the background in our Grasshopper app, we have some code that does beam sizing. If you change grid positions or if you change locations of the floor plate, the app reruns. The moment she's just kind of iterating and the visualization is changing, once we've found a position that we like, we can actually download those objects as beams that are sized to the Revit file. So again, this is a Grasshopper definition that we launch inside of Revit that can send information to the Revit model. Last one, obviously we want Revit's got a pretty good truss builder, right? It works pretty well, but at TT we find a lot of times we need to build more custom trusses. So this is an app we built in Grasshopper. We reference a beam from the Revit model, make some changes in the properties in Swarm, and then run the solution. Once we like the geometry we get, we can then bake it, use a Grasshopper term, into the Revit file. So maybe make some changes to the truss depth, truss type, and once we like what we see in the preview, we'll make that download to the Revit model. So again, this is us trying to build tools to increase efficiency and also kind of sidestep a little bit some of the pain that we all feel when we're using Revit as a modeling platform. All right, so Swarm is live currently right now. You can go to this website, swarm.thorntontomasetti.com. You can log in on the top right, and that'll basically give you access to our marketplace and allow you to download any of the free apps that are available. You can also be an author at this point and go to Grasshopper and create your own apps, which then can be used by other people inside of Revit and ETABS and SAP currently. Oh, sorry, also Rhino. So any of these apps would also run in Rhino. As well as the web. You have a web visualization you want to make. One note here, when you're signing up, we do prefer work email addresses. If you sign up with a Gmail, we think you're a little fishy. So just be aware of that. You want to give it a shot. Okay. I got more than 20 minutes this time, Andre.
Well, excellent.
Yeah.
Thank you.
You're welcome. Thanks, everybody. Questions? The industry. I think for engineers, it's a little different than architects. So because I work in an engineering company, I can probably speak more directly to that. Because our industry is mostly calculation, we think we can automate a lot of that calculation. So we're trying to build tools like the beam sizer you saw there, where that would be a hand calc an engineer might do for a client, like how big is the beam supposed to be? Well, we can codify that in the back end, and they don't have to worry about doing the sketch or the hand calc. It's taken care of. So our goal is to take away low-level tasks, allow them to focus more on high-level, big-picture stuff. For architects, I don't know, it's trickier to say. I think you guys, I mean, architects still have the same problems that buildings had 100 years ago, usually. It's a very difficult industry to push forward. I think better collaboration, more visualization of and sharing of models is a necessary evil, but we will leverage our models to a high degree at this point. We have to continue. So more high fidelity models. Who pays for the models? I don't know, to be honest, but we need better models if we're going to actually leverage any of the things that I've referenced here, machine learning in particular.
Saying more high fidelity. What is missing? If you're getting standard average architecture model, what is your first? Oh my God, why didn't they?
Well, standard structure. I mean, if you want to learn from data, it has to be formatted in the same way. So some firms have a really nice standardization across projects, but different projects are almost always treated as new things. So having every project start from I guess you call it a template maybe, would be one of the key things. For structural models, it's a lot easier. There's a lot less, I want to say, I mean, there's no door handles we have to worry about or hinges. It's the major structural object. So it's much easier for us to imagine a standardized data format we can eventually learn from our models. Architecture, it's much trickier. So that's the plan. We want to set up a means of storing information and learning from it. Yeah, so we do a lot of that. So a lot of the time it's architects got this crazy Revit Rhino model, and our job is literally get it into Revit. So we're very lucky to have spent a lot of time on Construe. That platform is 5 or 6 years old now, and it's pretty mature. So we can do anything that's a pointer or line, we can translate. So that falls most beams, columns, braces. Floor plates occur in that as well. Architectural objects, it gets a little trickier. We can do doors, windows. As you saw with Swarm, we kind of are trying to basically break down that barrier, is what I'm trying to say. We don't want there to be much difficulty in creating any object you can get in Rhino inside of Revit. I think even the fact that Revit now does a 3DM import kind of points towards that's what Autodesk think is necessary. I know we've been trying to solve this Rhino to Revit thing for years, and now Revit's like, oh, guess what? You can import 3DM. Now, it's not a real object, but it's a step in the right direction. We still think that native objects are the necessary. Yeah.
Sharing the memory space?
Exactly. That's basically what Swarm is built on. So what we're doing there...
You're taking that building up.
Yes.
Okay.
So Rhino Compute was the thing that Rhino released, would open up their geometry library. We're taking Swarm and are basically looking at their free library online to solve geometry problems. So it's basically Rhino Inside, or I think Nate Miller's got a version. Everyone's trying it because everyone has this problem. Our one is aimed specifically at structural engineers to start with, but very quickly we can see architects. Basically, anyone who can do something in Grasshopper has always wanted to be able to do that thing in Revit, and that's what we're trying to give them the capability to do. Or if you've used Dynamo in the past, anybody using Dynamo here? Who's got the Clockwork library installed? Because it's the Grasshopper data format, right? So people have been trying to make Dynamo look like Grasshopper for a while. We're now cutting Dynamo out of the loop, basically. It depends. Look, we're not trying to. Yeah. So for the studio audience, it was if we wanted to create a beam, would Dynamo not be better than, let's say, Swarm? Possibly yes. If you are the kind of user that knows how to use Dynamo, we've had in our company. We've had a lot of savvy Grasshopper users for a while, but not enough to get a critical mass. So the tools we showed are essentially trying to take away the programming part from people and just give them enough interface, does exactly what they want to do. So I guess we expect to use Dynamo for the right things, but this is really pitched at the kind of moderate user who doesn't want to even look at Dynamo. The baking is, yes, the last step, but it's not only baking, right? For the trib area tool, that's something where we like built a Voronoi algorithm and are just visualizing data for the engineers that they would do otherwise manually. You know, baking those detail lines, for example, super useful as opposed to bringing in CAD and referencing it. Also be 3D.
With data set, right? That's when people start cutting Dynamo out, going straight to Python, and then like me, like is this one thing more sturdy, more stable than?
Yeah, I would say yes, simply in the fact that it's running on Grasshopper as opposed to Dynamo.
Okay.
I've found Dynamo to be very unstable in general over the years, and Grasshopper is, I don't know, it's the opposite of that. Solid community, good support. The guy who wrote it will answer your questions, and it doesn't crash. Well, very, very rarely. So I think the benefit there is that it's Dynamo is at the least useful end of the spectrum, and Grasshopper is just far more stable. That's our goal. Yes. So what you saw earlier with Construe, this is an online database that is specifically for structural models. Every time you upload to the database, you're creating a new version. So right there, we have a history of models. It's then basically taking those linear histories of models and stacking up the projects on the other axis. And that's our data set that we want to learn from in the future. Now, we're much luckier than architects because we only have 10, 15 objects to worry about. Beams, columns, braces, floors, it's like in 2 hands worth of objects. When you get into the plethora of bits that can be in a building, it's far harder to standardize a format. It is. Well, I would say that doesn't get enough love, but the IFC format, IFC file format, Industry Foundation class, back in the late 80s it was developed, and it does provide a data schema that encompasses essentially everything you see in this room. So we have looked at, we thought about IFC for Construe, but we realized that it was just too much for what we needed. So we pared it down and just really focused on the structural objects. But the next step for Construe is essentially having an IFC plugin. Because then we can consume both architectural objects and structural objects at the same time. So I would say for the people out there that want to look at a shared data format for architecture, IFC is where you should start. And there really has a really good integration with Revit. Let's do it. Yeah. Yeah. I don't know. It's this. I would. Yeah. But I mean, don't you find that Dynamo just crashes too damn often? And look, if you're looking at about a, yeah. 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 It's a hard problem to solve. Look, there's a bunch of savvy users in our firm and a bunch of people who need to use those tools. It's interpersonal relations. It's going out and talking to that person, making sure they know what the tool's for, how to use it, I think we've been doing this for long enough in Core Studio that we've built a bunch of really nice tools. We've probably fallen down a little bit in our user outreach, getting the right tool built for the right user. So Swarm, because it's so iterative, there's no C# in the background, right? So anyone that can fiddle with a Grasshopper script can actually make the changes. So hopefully, because of the customization needed, it seems like we can make those changes quickly without having to worry about Dynamo crashing on us. That's the only reason, really. We just love Grasshopper a bunch. Anybody else? We do. Yeah, we have analytics on all of our tools. So any click on any of the tools there, and there's probably more than 300 different tools we've got currently, we track every click. So a big series. So it helps. It helps a lot. But you'll also find that you might have a bunch of people that click it once and never go back. Like, we need to know why. Those are the real issues. Mm-hmm. So knowing who's using what's great, but it needs to be more fine-grained. Yeah, there's a bunch of, interacting with users that's really, really critical in any of this development. Well, I mean, stuff like if
that's
we
what part of that question was.
Yeah.
Like, yes, a lot of awesome tools. Years, like, yeah, let's use the new stuff, and we go back and we have a couple of folks that are older than us that are all like, that's new. We got a couple of folks that are straight out of school that are like, yeah, but so much sexier than Revit. So I want to like Rhino and Revit. And how do you
use Swarm?
How do you? Well, part of it is use Swarm, but one thing that you guys as a company are doing is convincing end users, opening end users to using new tools. How do you like that didactic approach? I mean, it's not for right now, but
well, I think
back for that.
What we do is we show them something like that trib tool, right?
Mm-hmm.
If you show an engineer who is literally doing that manually, and it might take them 3 hours, and all you have to do is show them that video, and that's it. Walk away, and they will come find you and want to learn how to use the tool. So I think it's more about well, measuring trib is so lame by hand. Like,
yeah.
And there are many things in architecture that are lame to do by hand, right? So we're just trying to make tools that take away those 20 clicks, turn them into 1 click. No. So yeah, okay. So this looks very similar to the beam system tool, I would say, right? Revit's really good at laying out framing for you. This does not use beam systems. It's just placing individual framing instances. Full Revit beams. So the object that you see there, and I guess the trick here is that we're actually sizing it. So we are actually giving an a structural solution to the beam based on its length. So reference objects in, move grid lines around. What you'll see here is the profiles output. So the W18 is actually what gets downloaded as a Revit beam. That's critical. So we are always making native Revit objects. Well, we do actually also support adaptive components. So adaptive components are families in Revit that can pretty much be any geometry. We leverage those to build, doubly curved meshes, for example, and bring them into Rhino or to bring them into Revit. Structural framing examples are more for the engineers. We do have, inflate mesh using Kangaroo 2 and then bring that into Revit as panels, right? That's one example video we have. Swarm leverages all of the free plugins. So we have all the nice free stuff that Grasshopper has on our server. Paid for apps are obviously a different category, but anything that's free in Grasshopper can be built using. Yeah, so I don't have the Grasshopper interface here actually, but I could probably, I'll just show you some of the components. Yeah, we have inside of Grasshopper a whole series of authoring components. Perhaps so up here. So it's not so much create being, it's more about create object with attributes, a swarm. So there's means of creating, I mean, anything you can geometrically build and then add attributes to it can be baked into Revit. Cool.
I think that's it. The rest is moving downstairs to the bar. We're up for an hour. I'm sorry. I love all the questions. Don't get me wrong, but we need to be good guests to our host and not sit here until 9. That's what pub is for. Thank you, Thornton Tomasetti. Great as usual. Your book for next year.
Thank you, everybody. And I believe Andre will have a copy of the PowerPoint if you want